right, guys, now we are going to talk about evaluating functions. So right here we are given a function, y equals x squared minus 3. And we want to evaluate this function. And evaluating a function, what that means is figuring out what our output value will be when we are given a certain input value. So if we are given that x equals negative 2 as our input, we're going to plug that negative 2 into this equation and figure out what our output value is, or our y value is. So we'll have y equals, and everywhere that there's an x, we're going to replace it with a negative 2. So y equals negative 2 squared minus 3. And then we just solve this. So negative 2 times negative 2, or negative 2 squared, is going to give me 4. And then minus 3 is going to give me 1. So I know that if I input a negative 2 into this function, I will get a value of 1 as my output. And so I can fill that in my table. And then we can do that for all of our x values. So we'll do one more example with this. We'll have y equals, instead of negative 2 right here, we're going to put in negative 1 squared minus 3. And then we'll have negative 1 times negative 1 is 1. And then subtract 3. And 1 minus 3 equals negative 2. And so we can do that for all those values. All right, awesome. So we have the rest of our table filled in. And as you can see, we only have, each of our inputs has exactly one output. So this is a function. When you're evaluating a function, we just plug in the x value or the input value into the equation and solve for y or the output value.
All right, something you might see on your derivative assignment is not just filling out one function, but filling out two. So let's have another function. Just as we saw before, I'm just going to add another row down here. Y, and this will, I'll just put a little 2 there to show it's the second equation here. But we got 4x minus 6, just like we did before. If I want to evaluate for negative 2, I'm going to plug in negative 2 everywhere I see an x. 4 times negative 2 is negative 8, minus 6 is negative 14, I believe. Okay, all right, so now our table is filled out. Another question you might see on derivative is, what is the point of intersection? So if I were to graph our x squared minus 3, which is the one that Emma walked you through here, and if we were to graph 4x minus 6, which is the one I just walked you through just a moment ago, we want to find the point of intersection. So where, if I were to graph these, would these cross? So I want to look at their outputs, and do we see anywhere where the numbers or the outputs are the same? Yes, right here. We want to write this intersection as an ordered pair. So I would write this as 1 comma negative 2, because we write our x coordinate first and then our y. Kind of think alphabetical if you get those switched up. So this tells me that if I were to graph both of these functions, so if we were to graph x squared minus 3, which looks something like this, and if we were to graph 4x minus 6, it looks something like this. That means that they would cross at 1 comma negative 2. So this is just a rough sketch, but you can see that is their point of intersection. That is what visually it means from a table and on a graph. All right, this was kind of confusing because we had one function with y and we had another one which we named y2, and so we're going to introduce to you function notations. Instead of y, I'm going to call y f of x. The f usually stands for function, but this is a function of x. If I have another one, like in this case, y2, if I have a different function, usually we opt for g, but it's just whatever letter. G of x, and that tells me this is a different function of x. So instead of y's, now I can call them f of x and g of x. And this is just a way to help us understand or to rewrite functions as a function of x.
All right, so another reason that we like to write it in this function notation with f of x and g of x is because an easy way to write our input and our output values. So on your derivative assignments, you may see something like this. It'll say f of 1 equals something, and you have to figure out what f of 1 is. What this is saying is it replaced the x with 1, which is the same thing we did in the table up here when we plugged in 1 into our equation. This is saying the same thing. This is saying when my input value is 1, what will my output be? So f of 1 says when input is 1, what is my output? So we can see from our table, this is f of x function right here. So when x is 1, then my output is -2. And then we can also write that same thing with g of 1 equals -2. All right, we'll do one more example with this one. What if we instead were given f of 0? Then this is asking when my input is 0, what is my output? And we can come look at our table, and my input is 0, my output is -3. And then we can do that over here as well. G of 0, if we look at our input, g of 0 is -6. All right, now what if I was given something that looks like this? Do you guys see 10 in our table? No, but that's okay because earlier we learned how to evaluate functions. When we're given an input value, we can plug it into the equation to find the output value. So f of 10, we're just going to take 10 and plug it in here for x squared. So f of 10 equals 10 squared minus 3. So 10 squared is 100 minus 3 equals 97. That would take a really long time maybe to fill out all of the table. So if we have a value that's not in our table, we can just plug it into our equation. Same with g of 10. We can plug in 10 right here. So g of 10 equals 4 times 10, which is 40, minus 6, which is 34. All right, so the last thing we're going to talk about with this one is what if instead of being given the input value, you're given your output value? So this might look something like this. So what this is saying is if my output value is 6, how can I figure out what my input value was? So we're going to solve this the exact same way we've done with the other ones, except instead of replacing x, we're just going to replace f of x with 6. So instead of saying f of x equals x squared minus 3, I'll say 6 equals x squared minus 3. And we'll have to use our undoing skills from our solving equations unit to figure out how to solve this. All right, so I have 6 equals x squared minus 3, so I just replaced f of x with 6. So if we look at x, the first thing that happens to x is it's being squared, and then it is subtracting 3. So if we work backwards, we'll start here and we will add 3. So I'm just going to rewrite this equation right here. So I'll add 3 to both sides, which will create 0 there. And I'll have 9 equals x squared. And then I'll come over to this step, and this is something maybe you haven't seen in a while. We have x squared. So the opposite of an x squared is the square root. So we're going to take the square root of both sides, and that leaves us with the square root of 9 is 3, so x equals 3. All right, now we'll try it for g of x. So if we were given that g of x equals 6, then we're going to do the same thing we did on the last one, and then we're going to replace g of x with 6. So we'll say 6 equals 4x minus 6. And so now we'll write the story of x for this equation. Start with x, and then we multiply by 4, and then we subtract 6. We're going to start at our last step, and we're going to do the opposite, so add 6 to both sides. All right, so we have 12 equals 4x, and then we'll come to this step right here, and we have times by 4, so we'll divide both sides by 4. And this becomes 1, or just 1x, or just x, and we're left with x equals 3.
All right, another question you might see is, given a graph, can you identify what the inputs or outputs would be using that function notation that Emma was just sharing with us? For example, if this is a graph of f of x and it wants us to figure out what is f of 2, all right, well that means that 2 is my input and I want to know what is my output. So on my graph, remember my input corresponds with my x values. So I'm going to find 2 on my x values. Okay, here's 2, and then when I look at my graph, okay, it looks like that is the same as -2 as my output. All right, let's try another one. Again, this means when given an input of -3, what is my output? So I'm going to look at my x values or my input values here at -3 right here, and it looks like my output is 0. My y value is 0. So I would say that is 0. All right, we can also flip the script. What if they give us the output and they want us to find what the input is? What output gives us 4? So f of x equals 4, and they want to know what is our x value. This is telling me my output is 4, so I want to look at my y values, my outputs. Okay, 4 is up here, and it looks like this is 4. Sorry, we're a little crooked on here. That's okay. And then my input that gives me that is -2. So that means x would have to equal -2. If we were to plug it back in, we would say putting in -2 gives us 4. We can see here that there's some that might be kind of confusing. Like here, if I said my output is -2, well, there's lots of inputs that could give me that that, right? A lot of different values from 0 all the way to 3. We'll talk later about ways to describe that. So x could equal 0, or x could equal 0.5, or 0.82. There's a lot of different options here that can give me an output of -2. But it still is a function because it passes a vertical line test. It only crosses it at one point.